I've just finished doing calculations of strong acids and strong bases, and I ended up working problems where if I had 0.1 molar HCl, I knew that the pH was equal to 1. And I knew that if I had 0.1 molar NaOH, that the pOH was equal to 1. But you know, when you stop and think about it, you have probably never bumped into a normal human being who says the words 1 when they say pOH. You hear the word pOH and you go, what on earth is that? Where did that come from? Can't I just know the pH of my strong base solution? I mean, can't I have basic pHs? And the answer is you can have basic pHs, but it means converting your pOH into a pH value. And so at this point, I'm going to talk to you about conversion between acid and base terrain. Now, that may seem like an odd sort of thing to say, but bear with me as we show you this. Notice the following. Notice that water dissociates to make H plus and OH minus. And as a consequence, this means that water has the following dissociation constant expression. At room temperature. Let me minus log my way through this whole thing. When I do this, I end up with the fact that the pKw is equal to pH plus pOH is equal to 14. Oh my goodness. I think I've discovered right here in front of me a way to convert from my pOH into my pH. All I have to do is use this simple math equation right here. The pOH is 1, and I stick that number there. Therefore, the pH must be equal to 13. Similarly here, the pH is 1, therefore the pOH is 13 in this case. No matter what, because of my Kw equilibrium, the multiplication together of the proton concentration and the hydroxide concentration must always equal 10 to the minus 14. The addition of the pHs and the pOHs must always be 14 at room temperature, of course. So that I am always allowed to present my acid solution or my base solution results as either pHs or pOHs. And it's up to the person who's asking the question to define what terms they want for it. I could just as easily said, I want to know the pOH of 0.1 molar HCl, and you would have had to calculate pH first and pOH after that. I could just as easily have said, I would like to know the pH of NaOH, and you would have calculated pOH first, and then you would have calculated the pH second. So having been given a starting concentration of a strong acid or base, do understand that once you've calculated its H plus concentration or its OH minus concentration, you can simply write the reverse of these easily. This is a nice little trick to know to allow us to navigate between acid and base terrain, presenting stuff as an acid, presenting stuff as a base when we're doing our calculations. And you'll be asked to do this a lot on problems because the people who write them honestly don't care when they choose to ask you to write pH or pOH down. They'll just choose one randomly, then assign the compounds you're going to do the calculation for, and it's your job to ultimately get the units correct.